All right, in this lecture, we're going to look at the economics of information and choice, and we're going to study search theory. So often people don't do the math and calculate expected utilities or even expected values, and one can chalk up individuals' imperfect behavior as a lack of doing this math. But this other economic theory helps us understand why we don't always reach the layman's understanding of perfection in our decisions. Why we might not find perfect insurance rates or plans. We might not only make correct decisions all the time, or why we don't always have all the information about our daily lives, risk premiums, and all of that kind of stuff. What we're going to do is we're going to look at the economics of information and choice using this tool called search theory. You can use search theory to think about how much with imperfect information you spend in terms of time and effort trying to attain that perfect outcome or that perfect information. One frequently used example of search theory is to apply the tool to the optimization of finding a significant other. So we'll use search theory in that way to think about finding love the way it was meant to be discussed, with mathematics and an economic model. Search theory is an extremely general theory of economic action under uncertainty. There are two basic assumptions of search theory. First, the more time and effort spent searching increases your probability of successful discovery. And second, time is costly. The main conclusion that we'll get out of our search theory in looking for a significant other is that people will search so that the marginal cost of searching equals the expected marginal gain of searching. This is just the rule of rational life. Keep acting until marginal benefit equals marginal cost. So as a result, within our example of looking for the significant other, we'll see that there is no perfect one for you. Or more accurately, we'll see that even if there is a perfect one for you, the marginal benefit of finding that 1 in 3.5 billion probably isn't worth the cost of finding that 1 in 3.5 billion. So let's jump into a simplified model of mathematics in this economic tool of search theory. Within our example problem, we're going to say that the cost of searching for a spouse is $3,000 each and every time that you search. Right? So the cost of search is $3,000. The benefits you will receive from potential mates are uniformly distributed from 0 to $400,000 in value. This is uniformly distributed, not a normal distribution. So there's someone out there that's worth 0 to you. There's one person worth 1. There's one person worth 2. There's one person worth 3. There's one person worth 4, and so on up to 400,000. So it gets a really simplified distribution for us. We have this uniform distribution from 0 to 400,000. We're simplifying the dating market and suggesting that once you have dated someone, we will also assume that you could always also go back to them. Finally, we're going to think about how much benefit does someone need to provide for you to stop searching. When do you stop searching? Well, we have to break this down. The first thing that we're going to need is the probability of finding a higher payoff. What's the likelihood that we find someone who's better for us? Since the mates are uniformly distributed, we can look at what percentage of potential mates present a higher payoff. We can do that by taking the total payoff, the highest one possible, minus the current payoff that we have, and then dividing by the total. That would give us the percentage of people that are left that are better. What proportion of the remaining people are better than what we currently have? So if you found someone that had a payoff of 399,999, there would only be 1 in 400,000 chance of finding a better person. Take your W star here as your status quo, the level that you currently have. What you would see is if you currently had someone at 399,999, you would say the probability of finding someone better would be 400,000 minus W, or 399,999, divided by the total pool of 400,000. And so we would see that there is a 1 in 400,000 probability of a higher payoff. So what we want to do is we want to think of this W star as the amount that we currently are at. And this equation here would represent for us then the probability of getting a higher payoff from someone if we search. But we also have to know how much better off we become if we find someone better. We need the average gain given you find a higher payoff from searching. So if we find someone better, how much better are they likely to be? Again, we'll use the idea that mates are uniformly distributed, and this becomes rather easy for us. We can look at the best possible payoff minus our current status quo payoff, and then divide by 2 to find the average. So here we take the best possible payoff from our assumption from the example, 400,000, minus what we currently have, the W star, and divide that by 2. What we're doing is we're taking the amount that we're at, subtracting it from the overall total, and then saying, well, we'll end up on average in the middle of those two amounts. Right? And so what is the average remaining given that we have found someone better is what we're looking to do here. To think through why this equation makes sense, imagine you already had someone with a total payoff of 0. You're going to find someone better, but what, on average, do you expect the better payoff to be? Well, you would take 400,000 minus 0 and divide by 2. You would be right in the middle of the distribution at 200,000. And so this equation right here represents this element for us. If we're currently at 100,000 as our value, if we find someone better, well, then we would have a $150,000 gain to be expected on average if we plug in that 100,000 to this equation. So this equation represents for us the average gain given that you find someone with a higher payoff. Okay, so what is our expected gain? Well, simply multiply the probability that you find someone better with the average gain given that you found someone better to get the expected gain from search. And so this is what we have here, is the expected gain from search. We can take that 400,000 minus W divided by 400,000 and multiply it by 400,000 minus W star divided by 2. So what we have done is we have taken the probability of a higher payoff, 400,000 minus W star divided by 400,000, and multiplied that probability by the gain that we would expect if we got someone better off. And we end up with this 400,000 minus W star squared divided by 800,000. Then what we need to do is take the expected gain and set it equal to the expected costs. So you take the expected gain from the search and set it equal to the expected cost and solve for that W star. And that W star is going to become the optimal point where we would stop searching, where the expected gain of searching is now equal to the expected cost of searching. The solution will be the payoff from the spouse that leaves you indifferent between searching more and settling. Or in other words, where the marginal benefit of search is equal to the marginal cost of search. At that level of W star, you have optimized, and searching anymore yields higher costs to search than expected gains. In this case, we can take the expected gain, which we just solved for, and set it equal to the expected costs. And what we will get is a W star of our optimal stopping point of search at a value of a spouse when we have a spouse that is worth $384,508.07, not a penny less. So you're going to search until the expected gain is equal to this 384,508. You stop searching once you're at that point. Search theory can be extended to numerous other applications here. We can think of any time we're dealing in these worlds of imperfect information and gain from additional search or knowledge as being a potential application of search theory. You can think of research and development, of trying to develop some new products and things like that. You can think of just gold prospecting with search theory. You could think of finding the right home, just like finding the right mate. You can think of finding the right car in the same way, or deciding which college or grad school program to go to. All of these can be analyzed with the lens of search theory.